So the thing I want to talk about here is that I want to make sure that you understand these chromatography experiments. Okay. Uh, not sure how well it was explained in class. I want to make sure that you get the best. So again, over here in this little subunit, we have like different methods of separation. And when we talk about methods of separation, we are leveraging something that is very apparent, like some kind of physical properties that is very different. So when we say, oh, we use evaporation or we boil water to separate salt from water in salt water, it's because, well, salt is an ionic bond. Well, table salt has an ionic bond, which has a very high melting boiling point. But water, much lower. So we can evaporate all the water and just leave the salt behind. Now, when we talk about paper chromatography or column chromatography, we are using what difference to separate these compounds? Polarity, yes. Okay. Yeah. So first one is that you understand it's about polarity. And now the next natural question to ask is that, okay, so if you say polarity, which was the most polar, which was the least polar? Now, that question cannot be answered unless you know what the solvent is. If it has a non-polar solvent, as we did last week, remember how I put some permanent marker on the window and then we say, hey, you cannot use water to wash it. You have to use something non-polar to wash it, right? So if you have a non-polar solvent, that means the substrate or the compound that it's non-polar will move with the non-polar solvent. So that's why C would be the most or the most non-polar or the least polar. Okay. And A is the most polar because it is lagging behind. It's lagging behind since, polar solvents. Non-polar solvents and polar solutes, they don't go into each other hand in hand. So it's getting stuck behind. Okay. So, so make sure you know that. Okay. Make sure you know that. So column chromatography, again, it's about using the polarity difference to separate these substrates or these solutes from one and other. Okay. Okay. Same thing in question number 7, actually. It says substance X. Substance X is made up of two components, O and P. A small sample of X was dotted on the nonpolar chromatography paper, and a chromatogram was developed using polar solvent. The result is shown to the right. Which component is more polar? Well, since the solvent is polar, so whichever moves, well, so polar solute will move with the polar solvent. So which one's more polar? P. Okay. So because the solvent is polar, so when now, by the way, I want to make sure that we all understand this properly, because the picture right here it's not very clear on the illustration. So when we do paper chromatography, it's actually like this. And then you are putting this inside a little beaker. Okay. And then you insert you put no, actually a little bit lower. You don't want to touch the dot. So what we're saying here is that the solvent, it's polar. And then the solvent will go up against gravity up the paper. Okay. So whoever that's also polar will move with the solvent. And if it's nonpolar, it is not going to move with the polar solvent that quickly. So that's why the dot P is our polar, most polar, and the O it's going to be the least polar for this reason. Okay, so don't let the horizontal placement of the paper chromatogram confuse you. The paper it's by default nonpolar. Okay, but the main thing is what kind of solvent do you use? It's all about the solvent. You may choose polar or non-polar solvent, and then now one thing that I could also switch it up is to say, hey, this is the setting. This is the setting when you have a polar solvent. Now I'm going to change the solvent to a non-polar solvent. Okay, can you explain? Can you explain what will be higher and what will be lower? Then you would say, oh, in this case, my point O will be higher and my point P will be lower because my solvent is now nonpolar. So nonpolar solute will move more than the polar solute. Okay. So make sure you are well aware of the impact of the solvent. All right, let's take a look at number 8 as well. Another pair of chromatograms identify the unknown substance as either compound A or compound B. Now, this one is a little bit on math, and I think you all did this back in biology. Did you? The RF value? Did you? So, so for A and B, we say, what's the RF value? What's the reference value? It's just part of a whole. One quarter, which is 0.25, and this is 1/2. Okay. So so this is how we check the polarity. Okay, and then we say, hey, what about this? Well, for this unknown, the RF value is 0.5. Guess what it is. Okay, so make sure that you know it's about RF value. I know that you may not have this experience in class because we don't really do this kind of chromatography in class in a high school level, but it's a very common thing when you go to college level.